Hi, it's me, Gabe, here from Advanced Test Equipment Rentals, and today we're going to be going over Montana's new portable EMP short current injection system. They call it the PPG-188-125-1. This device is made to test protective devices per MIL-STD-188 and has an output amplitude of about 80,000 volts or 1200 amps of current. We have a few different ways we can couple the energy onto the circuit. We're going to go over that right now. So now we're going to take a look at the front panel of the pulse generator, and we're going to go over through some of the connections. So one thing, this light is on because we have the generator connected to the AC power cord, but it also runs off of battery, so it should last you about 24 hours if you're using the external or the internal built-in battery source. So I'm going to flip this switch to on, which now turns on the ready light. This is basically telling you that it's controlled by a PC using a controller hub that we'll get to in a minute here. The generator does have an emergency stop release switch, which I'm going to basically reset. And it has a key also where I can flip it to enable and I'll unlock the instrument. Like I said, this is the ready light. When the high voltage is enabled, the red light will come on, and if the interlock is removed or the emergency stop is changed, the yellow light will come on. If we want to rotate here to the side of the pulse generator, we have the interlock connection switch here. We have the AC single phase input to power on and charge the battery. We have the ground connection. Here we have the communication link that goes to your PC and the communication hub. And here's the business end. Here's the high voltage output, which is going to be an 8-meter long high voltage probe that'll get you to the injection devices. Now, if we go to the high voltage probe, currently we have it wired for a system verification test. So we have a current probe that'll measure the rise time and the amplitude of the current impulse, which we have that current probe connected to a optical converter. So we supply this with our rentals, and this will take that voltage and send it down as light into another optical to analog converter, which then goes to our oscilloscope, which let's go look at the software and the controller now. Now we're looking at the controller side of the system. On the other end of that fiber optic link, here's that fiber to analog converter I told you about. So you're going to have the electrical output come out of this cable, and it's going to go into our oscilloscope input. We also have the USB connection that has the fiber optic link communicate with our PC that we have over here on the right of the screen. And the controller also has the fiber optic link that communicates to the generator, which we just looked at. And on the PC side, it connects to another USB port on our computer on our right. So now we're going to show you how to configure the fiber optic link and then open up the software. So now that we have the system control software up, this is where it allows you to actually change your output amplitude in kV. So for example, at 5%, it's going to output about 4,000 volts. And I can turn it up to 100% and we'll see about 80 kV, 105% actually, but we'll drop it down to 100. When you're ready to impulse, you can actually press this trigger impulse. You can see the supply voltage and supply current by time. And you can see the history of different pulses you've had in the past. So you could export that to Word documents and print it out for your test reports. But yeah, let's actually, for our demonstration today, we're going to have it down at only 5%, which I believe is 4 kV. And we'll see how that looks like on the oscilloscope here. And now that we're ready to shoot the first impulse, I'm going to click this on button. And you see how the high voltage on just became red. And now I'm going to click on trigger pulse. It's charging and it should discharge. Now let's look at that on the scope. And as you can see here, our oscilloscope just caught the short pulse EMP signal. And you can actually characterize the rise time, how long the waveform is, the amplitude or the current that you're measuring. Keep in mind, there are attenuation settings within the software of the fiber optic link that you're going to have to convert to. So let's jump to that right now. So now to change the attenuation settings, we're going to dive back into the Pulse Lab software. Go to Edit. And right there, you could adjust the gain. So it was set at 0, but we're going to set it to -50 and hit enter. And they'll let you actually perform the measurement. So make sure you don't forget about that important step. And now let's go into how it's configured when you're actually testing an EMP filter or other product. Now we're going to go over ways we can actually couple the high voltage transient onto your product. So the first one is going to be a single line coupler. So we would slide our high voltage probe into there and then you can connect this to your device. Alternatively, we have a 4-wire system here, and we also have a bulk current injection coupler, which you can slide it in here and you could run the power cables through the BCI probe. Next, let's go over what other equipment we supply with our rentals. So now we're going to go over a few different important parts that we include of the system. So you're going to get 2 of these decoupling boxes, which essentially have 2 lines, and this is what the decoupling networks looks like. On this end, we're going to have the coupling end, and here you're going to have the auxiliary equipment side. You're also going to have 2 current monitoring probes, so you can measure the current going to and after your product, do some verifications there. And we also include a 0.2, 0.5, 2 ohm, and a 50 ohm resistance dummy load that you could use for your verification and acceptance testing. And if there's any more questions, please go ahead and give us a call or visit our website at www.atecorp.com.